All right. Ladies and gentlemen, distinguished guests and esteemed speakers, good afternoon. On behalf of the organizing committee, I would like to welcome you to today's international webinar titled Sustainable Energy Engineering Solutions Powered by AI. This event brings out together experts and professionals from around the world to share their insights, and we are delighted to have you with us and trust you will find this event informative and inspiring. I am privileged to introduce our keynote speaker, Dr. Senthil Kumar, Associate Dean of Karpaga Vinayaga College of Engineering and Technology, Chennai, India. And the second speaker will have Clarence Robas, Program Head of College of Information and Technology, WCC, and Dipolo Campus, Philippines. And our third speaker, Maya Utami Dewi, M.Kom. Okay. I extend my warmest regards to all esteemed attendees and participants. Let us commence this intellectual journey with respect and decorum. Before we commence with the substantive proceedings for today's esteemed international webinar event, a few administrative matters were in our attention. Firstly, I wish to highlight that today's session is being broadcast live on the Universitas STEKOM YouTube channel, ensuring accessibility to a broader audience. We will commence the event by singing the Indonesian national anthem as a mark of respect and national pride. Following this, I am disappointed to inform you that Dr. Joseph Teguh Santoso, Rector of STEKOM University, cannot attend today's webinar. But worry not, it is my distinct honor to invite Ms. Risma as our opening speaker. Before we move to the main event, with the commencement of main event, our esteemed panel of guests will share their expertise on the topic. Okay, we may continue. Let us begin with the moment of reference of and national pride, honoring our country by singing the national anthem. For the operator, please begin. All right. Following this solemn moment, I'm privileged to introduce an individual who will steer today's distinguished international event with grace and expertise. Please join me in extending a warm welcome to Ms. Risma, whose exemplary leadership and profound insights shall guide us through this enriching experience. For Ms. Isman Nurhafsari as the MFI CMM, the platform is now yours to deliver the opening speech.
Okay, thank you, Tania. Thank you to all participants enjoying us from different part of the world. It is great honor for me. Welcome you to this international webinar. And it's a Swiss sustainable engineering solution powered by artificial intelligence. On this occasion, I'm representing our rector who unconverted unable to attend due to another important commitment. And then, however, he extend his warm greeting and sincere appreciation to all distinguished speaker and participants who have joined us today. Today's theme is both timely and heavily relevant as we face global exchange such as climate change, energy efficiency, resource management, and sustainable development. Engineering innovation plays a crucial role. And then the integration of artificial intelligence into sustainable engineering solution has opened new pathways to create smart system, optimize resource, reduce environment impact, and build a more resilient future. And this webinar provide an important platform for knowledge exchange and collaboration and global partnership. It's also reflect our shared commitment to advancing technology not only for innovation but for sustainability and humanity. And we are truly honored to have their distinguished speaker with us today. First, Dr. Senthil Kumar, Associate Dean of Karpaga Vinayaga College of Engineering and Technology. And the second, Mr. Clarence C. Robas, Program Head of the College of Information Technology at VCC Antipolo Campus, Philippines. And the third, Ms. Maya Utami Dewi, M.Kom, a lecturer from the Information System Department of STEKOM University from Indonesia. We are confident the insight shared by our speaker today will broaden our participation and inspire a new idea implementation about artificial intelligence driven solution in sustainable engineering practice. And then I would also like to express our sincere gratitude to the organization commit for the dedicated and hard work in making this international webinar possible. To all participants, thank you for your enthusiasm and commitment to learning and collaboration. May this webinar strengthen international cooperation, ensure innovative research, and contribute meaningful to sustainable development worldwide. And thank you for the attention. Wishing you all a productive and inspiring session. Okay. Thank you, Miss Kania.
Thank you, Ms. Risma. And your wisdom and guidance are greatly anticipated and appreciated. With the opening remarks concluded, it is time to move on to the main presentation's focal point of today's event as we invite the speakers on the stage. I encourage all attendees to actively engage by posing questions in the chat feature, which will be addressed during the dedicated Q&A session following the presentation. Each presenter will be allocated approximately 30 minutes to deliver their discourse. Let us proceed with reference, enthusiasm, and a commitment to intellectual change. Thank you. Okay, for the first speaker, I invite you to welcome Ms. Maya Utami Dewi, M.Com, our first presenter from STEKOM University, whose expertise promises to illuminate our understanding of the topic. All right, let's begin our first insight by Ms. Maya Utami Dewi. The spotlight is now yours.
Okay, thanks, Ms. Kania, for your time. Firstly, I would like to thank you for the opportunity given by STEKOM University. It's a great pleasure to be here today to share my presentation with all of you. My name is Maya Utami Dewi, and I'm a lecturer specializing in information system in STEKOM University. In the international webinar with the theme Sustainable Engineering Solution Powered by AI, this time I will convey highlights the development of engineering system that leverage artificial intelligence to improve efficiency, adaptability, and sustainability. This topic emphasizes that future engineering solutions must integrate AI with strong data security and trustworthy system design. By combining intelligence, sustainability, and security, sustainable intelligence system enable resilient, responsible, and future-ready engineering innovation across various domains. Let me to show my presentation. Okay, for the first time, sustainable intelligence system integrating artificial intelligence and data security for future-ready engineering solution. Sustainable intelligence system are smart, data-driven system that use artificial intelligence to optimize resources, reduce environmental impact, and support long-term economic and social sustainability. These systems are designed not only to be efficient and adaptive, but also to minimize energy consumption, support sustainable development goals, and operate responsibly within complex engineering environment. Why we need AI for engineering sustainability? Modern engineering systems are highly complex and generate massive amount of data. AI is needed to analyze this data, predict system behavior, optimize energy use, and automate decision-making processes. Through AI, engineers can design solutions that improve efficiency, reduce waste and emission, enable predictive, and support sustainable innovation at scale. Importance of a secure as responsible AI. Secure and responsible AI is critical to ensure that intelligence systems are trustworthy, ethical, and resilient. Without strong data security, AI systems are vulnerable to cyber attack, data manipulation, and privacy violations. Responsible AI ensures transparency, fairness, accountability, and alignment with human and environmental values, making sustainable engineering solutions safe, reliable, and socially acceptable. Global sustainability trends are increasingly focused on climate action, clean energy, and responsible technology. Governments, industries, and universities worldwide are aligning with the Sustainable Development Goals, emphasizing carbon reduction, renewable energy, smart infrastructure, and circular economic models. At the same time, digital transformation and artificial intelligence are being widely adopted to improve efficiency, monitor environmental impact, and enable data-driven sustainable engineering solutions. Sustainable Development Goal. The Sustainable Development Goals are 17 global goals established by the United Nations to address major challenges such as climate change, clean energy, and sustainable cities, responsible consumption, and social well-being. They provide a global framework for aligning engineering and technological innovation with long-term environmental, economic, and social sustainability. Green engineering focuses on designing process, product, and systems that minimize environmental impact, improve energy efficiency, and promote the use of renewable resources. Digital transformation enhances green engineering by integrating technologies such as IoT, cloud computing, and AI to enable real-time monitoring, smart optimization, and data-driven sustainable solutions. Artificial intelligence play a key role in achieving sustainability goals by enabling predictive analytics, intelligent automation, and system optimization. AI support energy efficient operation, carbon emission reduction, smart resource management, and sustainable decision making across engineering sector. The role of AI in engineering. Artificial intelligence plays a transformation role in engineering by enable system to analyze large-scale data, learn from pattern, and make intelligent decision. AI enhance engineering process through predictive modeling, design optimization, automation, and real-time system monitoring. As a result, engineers can develop smarter, more efficient, adaptive, and sustainable solutions across various engineering domains. AI prediction, optimization, and automation. AI enables accurate prediction of system behavior, intelligent optimization of resources and processes, and automation of complex engineering tasks. This allows engineers to reduce energy consumption, prevent failures, through predictive maintenance, and improve operational efficiency. From design to operation, AI support the entire engineering life cycle from intelligent system design and simulation to real-time monitoring and operational optimization. It accelerates innovation, improves decision-making, and ensures system perform sustainability throughout their life cycle. Modern engineering systems are highly complex, interconnected, and data-intensive. AI helps manage this complexity by identifying patterns, modeling dynamic interaction, and enable adaptive, real-time control of large-scale intelligent systems. Intelligent systems are technology-driven systems that can sense their environment, process large volumes of data, learn from experience, and make adaptive decisions. By integrating AI, data analytics, and connected technologies, intelligent systems are able to optimize performance, respond to change in real time, and support sustainable and efficient engineering solutions. What makes a system intelligent? A system is considered intelligent when it can sense its environment, analyze data, learn from patterns, and make autonomous or semi-autonomous decisions to improve performance over time. Intelligent systems integrate data from sensor, connected device, and digital platform with advanced analytic and AI models. This integration enables real-time monitoring, predictive insights, and optimized system control. Through machine learning, intelligent systems continuously learn from new data experience. This allows them to adapt to changing environment, improve accuracy, and enhance sustainability and efficiency over time. AI is widely used to improve energy efficiency by analyzing consumption pattern, predicting demand, and optimizing system operation in real time. In sectors such as smart building, manufacturing, and power system, AI enable automated control of lighting, machinery, and energy distribution, significantly reducing energy waste, operational costs, and carbon emission. Smart building, AI optimize HVAC and lighting to save energy. AI has enabled energy consumption reduction of over 25 until 30% in smart building energy system. In smart building, AI optimizes its VAC system and lighting by analyzing occupancy pattern, weather condition, and real-time energy used. Through intelligent control and predictive adjustment, AI-driven building systems have demonstrated the ability to reduce overall energy consumption by more than 25 until 30% while maintaining occupant comfort and operational efficiency. Case AI-driven grid management. AI-driven grid management use machine learning and real-time data analytics to monitor energy demand, predict load pattern, and optimize electricity distribution. By intelligently balancing supply and demand, integrating renewable energy source, and detecting failure early, AI help reduce energy loss, improve grid stability, and support more sustainable and resilient power system. The Simon next Gen Grid AI system leverages artificial intelligence to monitor real-time energy use and seamlessly integrated renewable energy source into the power grid. By using predictive analytics and intelligent automation, the system has demonstrated up to a 20% reduction in energy waste and a 15% improve in operational efficiency, supporting more sustainable, reliable, and resilient energy infrastructure. Case AI for sustainable building material. AI is increasingly used to accelerate the discovery and design of sustainable building materials by analyzing large data set of material properties and environmental performance. Machine learning model can identify optimal composition that improve strength, durability, and thermal efficiency while reducing environmental impact. This improves short-term research and development time and support the creation of eco-friendly material that lower energy consumption and carbon emission in the built environment. AI design falling pattern, machine learning design accelerate discovery, and recent research published in Nature 2025 shows how machine learning was used to rapidly design an advanced cooling fan with high solar reflectivity and thermal emission. The AI designed material can potentially reduce building surface temperatures by 5 to 20 degrees, significantly lowering the need for air conditioning and cutting energy consumption for cooling, making it a promising solution for sustainable urban environment. AI carbon emission reduction by analyzing large-scale environmental and operational data to predict emission, optimize energy usage, and improve industrial processes. Through intelligent modeling and automation, AI help organizations monitor carbon footprint in real time, identify inefficiencies, and implement data-driven strategies to reduce greenhouse gas emission across engineering systems. Building energy consumption and carbon footprint modeling, AI could help reduce carbon emission up to 19% by 2050. Building energy consumption and carbon footprint modeling. AI enable advanced modeling of building energy consumption and carbon footprint by analyzing sensor data, weather condition, and operational pattern. This model support accurate prediction, real-time optimization, and strategic planning to reduce energy use and environmental impact. Recent studies indicate that AI-driven optimization and intelligent system design could contribute to reducing global carbon emission by up to approximately 19% by 2050, highlighting AI's significant potential in supporting long-term sustainability and climate action.
Angel bikin semangat.
Integrating sustainability and AI means designing intelligent systems that not only optimize performance but also minimize environmental impact and support long-term social and economic goals. By embedding sustainability principles into AI-driven solutions, engineers can optimize resource usage, reduce waste and emission, and enable smarter, more responsible decision-making across engineering system. AI for resource optimization, circular economic frameworks using AI. Example, optimizing waste management flows. AI for resource optimization, AI optimizes the use of energy, material, and time by analyzing operational data, predicting demand, and improving predicting demand, and improving system efficiency. This enables engineering system to reduce waste, lower costs, and maximize sustainable performance. AI supports circular economy model by enabling intelligent sorting, predictive maintenance, life cycle analysis, and smart reuse of material. These capabilities help close resource loops and minimize environmental impact. Example, optimizing waste management flow. In smart waste management system, AI analyzes collection data, sensor input, and city activity pattern to optimize collection routes, improve recycling rates, and reduce fuel consumption and landfill waste. Data security and sustainable AI. Data security is a critical foundation of sustainable AI system. As intelligent engineering solutions rely on large volumes of sensitive and real-time data, strong cybersecurity measures are required to protect data integrity, privacy, and system reliability. Secure data pipelines, robust encryption, and resilient system architecture ensure that sustainable AI solution remain trustworthy, safe, and operational in the long term. Protecting data in intelligent system important of privacy and secure data pipelines. Protecting data and intelligent system. Intelligent system continuously collect, transmit, and process large volumes of data. Protecting this data is essential to ensure system reliability, prevent manipulation, and maintain trust in AI engineering solution. Importance of privacy and secure data pipelines. Secure data pipeline and strong privacy protection mechanism ensure that sensitive information is safely collected, stored, and processed. This prevents data leak and unauthorized access and misuse while supporting ethical and responsible AI implementation. Cybersecurity risk and mitigations. AI-based system face cybersecurity, such as data breach, model manipulation, and system disruption. This risk can be mitigated through encryption, access control, continuous monitoring, and secured by design system architecture. Challenge in sustainable AI. Sustainable AI face several challenges, including high energy consumption of AI models, limited data quality and availability, integration complexity, and ethical and security concern. Engineers must balance performance, environmental impact, transparency, and data protection to ensure that AI-driven engineering solutions are truly sustainable and social responsible. Data available and quality. The effectiveness of sustainable AI depends heavily on the availability, accuracy, and representativeness of data. Poor quality or biased data can lead to unreliable prediction and unsustainable engineering decision. Sustainable AI must address ethical issues such as fairness, transparency, and accountability, as well as security risk and privacy protection. Without responsible development, AI system may create social harm or expose critical engineering infrastructure to cyber threat. AI system often require significant computational power, data storage, and energy consumption. Managing this resource demand is essential to ensure that AI solutions do not undermine sustainability goals. Responsible AI practices ensure that artificial intelligence systems are developed and used in ways that are ethical, transparent, secure, and aligned with human and environmental values. This includes fairness, explainability, accountability, privacy protection, and sustainability consideration throughout the AI life cycle. Example, principle, transparency, accountability, and fairness. This principle ensure that AI system operate openly, decision can be audited, and outcomes do not create bias or discrimination. They are essential for building trust in AI-driven engineering solutions. Explainable AI enable engineer and stakeholder to understand how AI model generate prediction and recommendation. They support safer engineering decision, regulatory compliance, and responsible system deployment. Example of ethic framework. Ethic framework such as the OECD AI principle, UNESCO's AI ethic recommendation, and the EU Transversely AI guidelines provide structural guidance for developing and deploying responsible, human-created, human-centered, and sustainable AI system. AI lifecycle and sustainability focus on embedded environmental, ethical, and efficiency consideration into every stage of an AI system, from data collection and model development to deployment, operation, and long-term maintenance. Sustainable AI ensure that systems remain energy efficient, secure, transparent, and aligned with long-term engineering and sustainability goals. Design, development, maintenance. The life cycle span from system design and data strategy through model development and testing to development and long-term maintenance. Each step influence system performance, security, and environmental impact. Sustainable AI requires energy efficient model design, responsible data management, secure deployment, and continuous monitoring to reduce environmental footprint, maintenance system reliability, and ensure ethical and responsible operation over time. Sustainable software maintenance case. Sustainable software maintenance uses AI-driven monitoring and optimization to improve system performance, reduce unnecessary resource consumption, and extend system lifespan. Through predictive maintenance, automated testing, and intelligent resource management, AI help minimize energy usage, reduce operational costs, and support long-term sustainability of engineering system. AI can improve software project sustainability by reducing energy usage and optimizing computing resources during maintenance phases. AI improves software project sustainability by monitoring system performance, predicting maintenance needs, and dynamically optimizing computing resources. During maintenance phases, AI can reduce unnecessary processing, optimize server workload, and lower energy consumption, helping organization and maintain reliable system while minimizing environmental impact. Policy and governance aspect. Policy and government provide the regulatory and ethical foundation for sustainable AI and engineering system. They define standards for data protection, energy efficiency, transparency, and accountability, ensuring that AI-driven solutions are aligned with sustainability goals, legal requirement, and social values. Standard for reporting energy use, especially data center. International standard and framework increasingly require organizations to measure and report energy consumption and carbon emission, particularly in energy-intensive environment such as data center. This standard promote transparency, efficiency, improvement, and accountability in sustainable engineering system. Regulatory trends for sustainable AI. Government and global organizations are developing regulation that encourage responsible and sustainable AI, focusing on data protection, ethical use, environmental impact, and risk management. This regulation aim to ensure that AI innovation support long-term sustainability goals. Importance of sustainable metric. Sustainability metric provide measurable indicator of environmental and operational impact, such as energy efficiency, carbon footprint, and resource utilization. These metrics are essential for evaluating performance, guiding engineering decision, and continuously improving sustainable AI system. Future research direction. Future research in sustainable intelligent system will focus on developing more energy efficient AI model, advanced predictive system for climate and engineering application, secure and explainable AI, and deeper integration between AI, green engineering, and social impact. This direction aims to create smarter, safer, and more sustainable engineering solutions. Cross-disciplinary sustainability research. AI for advanced energy modeling. AI enables high-precision energy modeling by analyzing large-scale sensor, climate, and operational data. They support accurate forecasting, system optimization, and smarter planning for sustainable energy system. Large language model in sustainable design by assisting engineers in data analysis, simulation interpretation, design decomposition, and decision support, accelerating innovation in sustainable engineering solution. Sustainable engineering increasingly requires collaboration across engineering, computer science, environmental science, social science, and policy. Cross-disciplinary research enables holistic solutions that address technical performance, environmental impact, and social responsibility. Implementation roadmap. An implementation roadmap provides a structured approach for developing a sustainable intelligent system. It outlines key steps such as defining sustainability objectives, preparing secure and high-quality data, designing and training AI models, deploying intelligent solutions, and constantly monitoring performance, impact, and risk. This roadmap ensures that AI-driven engineering solutions are aligned with sustainability goals, data security, recruitment, and long-term system resilience. identify sustainability goals. The first step is to define sustainability objectives such as reducing energy consumption, minimizing carbon emission, improving resource efficiency, or supporting social and economic impact. This goal should align with organizational strategy and global sustainability framework. Data strategy and security blueprint. A strong data strategy ensures that the availability of high quality, relevant, and ethically sourced data. A security blueprint defines how data will be protected through secure architecture, access control, encryption, and continuous monitoring, ensuring trust and system resilience. AI models should be designed to directly support the Sustainable Development Goal, embedding sustainability indicator, fairness consideration, and environmental impact metric into system objectives and performance evaluation. Okay, and the conclusion. Today, engineering challenge climate change, energy efficiency, and digital resilience cannot be addressed by traditional approach alone. Artificial intelligence offers unprecedented opportunities to transform engineering into a more sustainable, adaptive, and impact-driven discipline. Sustainable intelligence system empower us to predict, optimize, and innovate at a scale that was previously impossible. Yes, the true success of AI-powered sustainability depends on how responsibly we design and govern this system. Secure data infrastructure, ethical AI practices, and sustainability-aligned strategies must become integral part of engineering solution. By uniting AI innovation with sustainability values and the sustainable development goals, we can collectively set a future where technology not only advance industry, but also protect our planet and society. Okay, that's my presentation. For the next time, I return it to Miss Kania. Miss
All right.
Kania, yeah,
Yes.
okay.
All right. Thank you, Ms. Maya Utami Dewi, for the presentation. It is a very insightful presentation. Um, and I apologize for skipping Dr. Senthil because he cannot join us today for the webinar. So, uh, for our second speaker, I invite you to acknowledge Ms. Clarence Robas from College of Information Technology, WZT Antipolo Campus, Philippines.
Good afternoon, everyone.
Okay.
Good afternoon, STEKOM University. So today, I'm going to discuss about the future of sustainable technology. So let me just present my PowerPoint in a while. Okay. So can you see my PowerPoint? Okay. So again, today I'm going to discuss the future of sustainable technology. So before I proceed with the presentation, so let me just introduce myself. So I'm Clarence Robas from Road City College's Antipolo. and I'm currently the program head of the College of Information Technology. So currently, I'm handling capstone research for the IT and as well as the software development and other computing and multimedia subjects. I also presented research about AI, computing, and related discipline in local and international research conference. I also delivered several seminars about technology and multimedia across different schools. Okay, so let's proceed with the topic. So, what are the objectives for this topic? So, the first one is to understand the concept of sustainable development and technology. The second one is to describe the role of sustainable technology in different disciplines. And the last one is to reflect on the importance of sustainable technology for the better future. So the main goal of this topic is for you to understand what are the possibilities when we include technology to the sustainable development. So here are the topics that we're going to tackle today. So we have 6, and let's start with the context. So in terms of the context, as of the early quarter of 2026, the global situation with regards to the sustainable development is progressing but quite slow to what is actually expected. While some indicators like renewable energy, social protection coverage, etc., show promise only about 18% of the United Nations Sustainable Development Goals. And with the emergence of technology, sustainable development is expected to continuously grow and improve for the next couple of years. And therefore, according to Google, sustainable technology or the integration of technology and sustainable development is moving to a pragmatic, operational, imperative driven by financial realism, energy security, and AI driven efficiency. It is becoming embedded into core businesses, strategies, supply chains, and infrastructure. But with this context, the question is there a promising future for sustainable development? So let's check later. But first, let me introduce what is the concept of sustainable development. So when we say sustainable development, it is defined as development that meets current needs without jeopardizing future generation ability to meet their own needs while also balancing economic growth, social inclusion, and environmental protection. Meaning, when we say sustainable development, it involves three things. The first one is the social progress. Second is the environmental protection and enhancement. And the last one is the economic development. So they need to be balanced. Okay. So with the sustainable development, they have or it has a 5 principles. So these 5 principles are first, the conservation of ecosystem and environment. Second is the conservation of the biodiversity of the planet. So these two focuses on the environment protection and preservation. So the third one is the sustainable development of the society, which one of the example is the responsible consumption. Next is the conservation of the human resources, and lastly is the population control and management. So with these 5 principles, we have the 17 sustainable development goals. So I think most of you already familiar with this one. So the 17 sustainable goals were adopted by the United Nations and it composed of 17, like what I've said. So the first one is the no poverty, zero hunger, good health and well-being. We also have the quality education, gender equality, clean water and sanitation, affordable clean energy, decent work and economic growth. We also have industry innovation and infrastructure, reduce inequalities, sustainable cities and communities, responsible consumption and production. We also have climate action, life below water, life on land, peace and justice, strong institutions, and lastly, it is the partnership for the goals. So in the Philippines, we already slowly integrating the 17 Sustainable Development Goals. So for example, in our department, the College of Information Technology here in World City Colleges, we integrate the SDG or the Sustainable Development Goals in our capstone project wherein students should have developed a project that is relevant to the SDG. So one of the example is one of my students develop an application about the basics of medical terminologies. So the beneficiaries are the medical students, specifically the nursing and medtech students. So these applications pertain to the SDG goals number 4, which is the quality education. And another one of my students developed an application relevant to the tourism promotion of the National Museum in Anthropology here in Manila. So this also related to the SDG number 4, which is the quality education. And these two students already presented their studies in a international research colloquium that which was held last year. So with that, with the emergence of the technology, uh, we have a new term that is called the sustainable technology. So what is a sustainable technology? So sustainable technology involves the use of engineering or rather the technology to create products and solutions that are designed to meet current needs without hindering the future environment. So it's more of integrating the technology without compromising the environment. So this aims to address the urgent environmental and social concerns by promoting environmentally friendly behavior, resource conservation, as well as reducing the environmental damage. So what are the key benefits of sustainable technology? So we have primarily 4. So the first one is the reduction of the operational cost. So of course, since we're using technology, we can promote energy efficient technologies wherein companies can take this as an advantage to reduce energy and water consumption as well as minimize waste generation. So the second one is improve corporate reputation, wherein companies can adopt the sustainable practices which are viewed more favorable by the consumers and investors. So they see it as a good image to the company since they're thinking that adopting SDG by the company is like your care to the environment or the people or the community. So the third one is the regulatory compliance. So with the increasingly stringent environmental regulations, companies can adapt to avoid the fines and penalties. Especially here in the Philippines, there are a lot of compliance that are related, for example, about environment. No, they have to secure permits for that. So with SDG, companies can adapt to avoid this possible fines and penalties from the local government. So the fourth one is innovation. So sustainable technology can drive green innovation. So this creates a new business opportunities and markets, particularly for multinational corporations. Later, you can see that there are what we call the new companies that came from the green innovation. So later we will see. So what are the examples of sustainable technology? So the first one is the solar powered systems. You also have the smart energy grids and also the AR driven optimization tools, which are commonly used in manufacturing and energy consumption management. So what are the sustainable technology integration in different discipline? So let's see. The first one, transportation and automotive. So the one of the common thing or the most important thing that comes into our mind when we say transportation and automotive and sustainable technology is electric vehicles. So this has been developed for years, but their rapid advancement continues to shape sustainable transportation. So as you know, EV vehicles are slowly, in our trends now in, especially here in the Philippines, BYD are one of the, and also the VinFast are one of the common EV vehicles that for me, personally saw in the major highways here in the Philippines. And also one of the example are the Tesla vehicles. So this is one of the well-known electronic vehicles which has an autopilot system that enables navigation with minimal driver intervention. So another example of electric vehicles are what just like what I've mentioned earlier is the BYD, more specifically the Seal model, and also Tesla. Nissan also releases a new uh, line, which is the Model Leaf. Yeah, so they market it as 100% electric car, and also VinFast, which is one of the well-known electric vehicle here in the Philippines. But if I'm not mistaken, this is from Vietnam. So yeah, correct me if I'm wrong. So another thing is the Green GSM. So this is the first electric vehicle-based taxi operating in the Philippines. So this was launched last year, and this is commonly seen in the Metro Manila roads, like somewhere in Makati, Taguig, Pasig, and Caloocan. And this taxi can be accessed through an app. And if I'm not mistaken, these vehicles are VinFast cars. So they are 100% electric cars. Also, last year, April 2025, so the Valenzuela city government rolls out 41 electric cars for police department. So this initiative is part of their Go Green program. And this is also the first city in the Philippines that has the largest fleet of electric vehicles in police operation. So mainly they are using this for the police operations. And if I'm not mistaken, if I'm not mistaken, this model they using is BYD Seagull, if I'm not mistaken. So they also have a dedicated EV charging station. Well, actually, I always saw this every time I go to church in Valenzuela City. So they have this dedicated charging station, and their e-cars are just roaming around the city. So yeah. So the next one is the energy and utilities. So when it comes to the energy and utilities, so it pertains to the, like for example, smart grids. So the aim is to optimize energy distribution and renewable sources like solar and wind power. So for example, we have here the different power sources like the wind energy, solar energy, nuclear, or thermal. So these are connected to a smart grid wherein the main job is to manage these power sources and distribute this to the specific community or city. So one example is from Huawei Smart Grid solution. So what is Huawei Smart Grid solution? This technology enables digitization of power grid through full stack ICT technology. So this solution involves the cloud management, edge, and end. So their goal is to establish a comprehensive grid state awareness and as well as intelligent interconnection and support to secure safe, reliable, and efficient power grid operation. So one of the latest project by Huawei is the State Grid Shaanxi in China, wherein Huawei introduced an intelligent power distribution solution using a cloud pipe edge device architecture, which enables real-time monitoring of transformer districts and improves smart services. So with this kind of technology, it delivers a greener, more stable, and safer power consumption for the users. So the next example is the Pililla Rizal windmill farm in the Philippines. So this windmill farm is acquired the IFC Sustainable Energy Finance Award. So this is one of the first in to finance a feed-in tariff project without recourse. And this project is a form of collaboration between the provincial and local governments here in Rizal province in the Philippines. So this windmill farm composed of 27 wind turbines which generates 54 megawatts of power for roughly 66,000 homes. So around Pelilla Rizal and its close neighboring provinces like Tanay and Baras, Teresa, etc. So also we have here the Energy Conservation Program of Pan-Pacific University. So it was established in the year 2023, wherein they partnered with the W Energy Power Pilipinas. So they installed solar panels in their buildings to reduce carbon emissions and also to produce solar clean energy. So, and also it's cost efficient for their university. And if I'm not mistaken, they also proposed this into Wuri. So they won an award because of this one. So for the construction and real estate, so sustainable technology also involved with this one. So this also called as sustainable construction. So green building materials uses like bamboo, recycled steel. Sometimes they also use recycled plastics to build buildings, and also LEED certified self-sufficient buildings. So what are the example of um, construction and real estate in sustainable technology? So one of the best example is the One Central Park in Sydney, Australia. So they are well known for its vertical garden. So as you can see here, this is the actual building, and they have here the vertical garden. So it's like, imagine a garden, but it's in a vertical way. So this is a 64,000 square meter park, which is also inspired in New York Central Park. So it serves as a lush and tranquil gathering space where visitors can unwind and enjoy quality time with friends and family. So this um, vertical garden also helps to cool down the air ventilation around the building, and also to give clean or fresh air to the tenants and to the people who are here in the One Central Park. So the next one is the smart HVAC and lighting, so which uses electrochromic glass and motion sensor LEDs to reduce energy use. This is also common to the business districts, especially those who own international companies, like for example in BGCs and Makati. So high-rise building, they use this kind of technology to reduce energy consumption. In addition, uh, Internet of Things or IoT are used to manage energy for smart homes and buildings. If I'm not mistaken, Samsung first introduced this kind of technology wherein, for example, in a smart home, for example, you're away from home, you forgot to turn off the TV or turn off the lights. So IoT automatically manages the energy consumption, so they turn off all the devices or the appliances there. So it will be very efficient, especially for energy consumption. So when it comes to agriculture and food, so one of the example of the integration of sustainable technology are the precision farming, vertical farming to reduce the land and water use, as well as food waste reduction technologies like APIL. So one example, or one of the best example of the integration of sustainable technology for agriculture and food is the smart irrigation using the Internet of Things and AI. So on this project by Yunus Emre et al., so they developed a system that integrates IoT and AI based for the irrigation system. So this help enhance the agricultural productivity of certain agricultural land. For example, this smart irrigation can be integrated in a greenhouse or an actual farmland. For example, rice fields or vegetable fields. So this not only help the farmers when it comes to the labor, but also it will be very efficient when it comes to the irrigation management. No? So in addition, Ateneo de Manila University here in the one of the premier university here in the Philippines they have what we call the Ateneo Innovation Center on that university. So they develop a long-range or LoRa-based sensor monitoring system in their hydroponic system. So what is it? No? So this one is a type of system that installed to, sorry, ayan. This technology are installed in a dedicated greenhouse to enhance the precision agriculture, specifically in a black rice cultivation. So this system has a 7-in-1 sensor which aim to collect data and different crucial parameters, primarily connected to water supply. So this also monitors the crop temperature, humidity, pH levels, electrical conductivity, NPK, which is called the nitrogen, phosphorus, and potassium, as well as the salinity. So these data are used to analyze the crop health and also to help the farmers to provide or to have a better solutions for their crops. So in addition, here in the Philippines, last April 2024, the International Rice Research Institute and the Department of Agriculture, Philippine Rice Research Institute, launched the project Drones for Rice. So they're using the drone, no, to integrate in farming, wherein you can use drone to plant seeds, put fertilizer to the crops, and pesticides for rice production. So this is more efficient, especially for those farmers who are still using manual to manage their land. So when it comes to IT and data centers, sustainable technology are very, like for example, the cloud computing. So cloud computing is one of the common when it comes to the sustainable technology, wherein it can improve the energy efficiency by up to 93% compared to the local servers. So one example is the Eco Data Center in Sweden. So this is what they call the Sweden Green Data Center. So this is the data center they had. So they also call this as a climate positive data center. So this innovative project aims to make a fossil-free welfare country by 2045. So this is a global first in emission reduction goals that sparks great interest. So this project also projected to expand to around 2.13 billion pounds by 2029. So this harness a renewable power to slash carbon emission output. In addition, we also have a project NATEC. So this is a project made by Microsoft to determine the feasibility of subsea data centers. So meaning they're going to install a data centers under the sea. So like this one. In terms of manufacturing and waste management, so sustainable technology focuses on the carbon capture and storage, or the CCS. We also have the wastewater treatment systems and advanced recycling technologies for electronics and plastic. So one of the common application of the sustainable technology is the smart waste management system and staff tracker app, which was developed in Legazpi City, Philippines. So this system enhanced the efficiency in waste management operation in terms of real-time recording of solid waste data, wherein this recorded data is sent to the system, and these are used for data analytics and decision support for the local government of the Legazpi for more manageable waste management system in their city. So we also have what we call the digital twins. So when we say digital twins, these are virtual replicas of factories, like for example, the LG Electronics and Procter and Gamble, to simulate the production. So with this technology, it leads up to 30% of reduction in energy and inventory. So one example is the BMW's digital twin factories, the one in Regensburg. So this represents a key sustainable, efficient, and innovative approach to manufacturing and reduce planning time by almost a third, and providing a virtual real-time replica of the entire production site. When it comes to retail and consumer goods, so sustainable technology focuses on the digitalization to reduce the paper waste and sustainable AI-driven supply chain management. So what are the example of this? So the first one is the AI-driven supply chain management. So meaning these are the supply chain management integrates with the artificial intelligence. So they are using machine learning, predictive analytics, and automation to enhance efficiency, and also to reduce costs and improve visibility, while lowering the logistic costs. So one of the example is the audit and identify bottlenecks, so which evaluate the current processes to identify the inefficiencies such as the inventory bottlenecks or forecasting errors. So AI can help to provide this kind of value. Another example of integration of AI to the supply chain is the AI-enabled smart freezers by Unilever. So Unilever uses AI-equipped IoT-enabled freezers to track the inventory levels, temperature, as well as the maintenance, to reduce energy waste and minimizing the product spoilage. So this is really helpful, no, especially to prevent the food waste, and also to, you know, to reduce the energy waste when it comes to the usage of this kind of freezers. Another thing is the Orange app, which is currently used by the World City Colleges. So this system promotes a paperless and digital learning. So this is an e-learning management platform that integrates SIS, or the Student Information System, and the Learning Management System. So wherein student can take exam activities online, and also on the teacher side, they can post the grades, make assessment or lesson, and also in administrator side, they can streamline online enrollment, and which leads to the more efficient and technology-driven school operation, since it's paperless and digital. So with this trends, so what is the power of AI when it comes to sustainable development? So as we all know, AI is the current trends right now when it comes to technology. And artificial intelligence has become one of the most transformative technologies which supports sustainability and environmental goals, which acts as a powerful tool for accelerating transition for greener future. But we have to make sure in using this AI that we have to be more responsible, since AI is very powerful, you know. And with that, there is what we call the double-edged sword. So, what are the possible key challenges in this one? So, the first one is the high energy consumption. Since training a large AI models requires a massive carbon footprint. The next one is the e-waste. Since the development of technology is rapidly fast, so the demand when it comes to electronic gadgets are really high. So that's why it also increased the electronic waste. The last one is the data requirements. So this depends on the high quality, often personal data, and raising privacy concerns when it comes to the data. So what is the future of sustainable technology, particularly AI? So to maximize AI's potential, so we should focus in shifting toward the green AI, more on developing an energy efficient algorithms and using renewable energy to power data centers. So the main goal is to make AI a partner in building a sustainable net zero future. So in terms of sustainable technology, it is important to note that sustainable technology can shape how humanity will live, work, and grow while protecting the planet. So, the future focuses on creating systems that meet today's needs without compromising the ability of future generations to thrive. So, there are a lot of applications when it comes to sustainable technology, and we have to, you know, think outside the box to help the community to grow when it comes to sustainable uh when it comes to sustainable development. So what are the future trends? So we have AI for sustainability. We also have the circular economy and bioeconomy, which is more on converting waste into resources. We also have more advanced energy solutions, and also the digital sustainability and ESG reporting, which integrates blockchain. For the call for action, there is a promising future for sustainable development as long as we utilize AI and technology in general in an acceptable and ethical manner. It is up to us how we will integrate technology for sustainable development. So through responsible technological advancement, we can live better lives without compromising the sustainability of natural systems. Especially the youth, no, I encourage you to use technology to improve the sustainable development of your community. So with that, to end my presentation, let me share to you a quote inspired by our national hero, Jose Rizal, which is, "The youth are the hope of our future and the innovators of the sustainable better world." So I hope this presentation helped you to be inspired, no, to create something innovative that could help the community or uh the country, no, when it comes to sustainable development. So with that, thank you so much for giving me opportunity to present this topic. So thank you so much.
All right. Thank you so much, Miss Clarence, for the insight on how sustainable AI energy can be used towards everyday life. All right. What incredible insights that we go from our speaker today. So to make this webinar complete, we will now transition to a structured question and answer or Q&A session to explore the topics presented by our distinguished speakers in greater depth. Our esteemed speakers are ready to engage with you and provide further insight. So we received several overlapping questions for both speakers, so we've combined the Q&A session to get richer perspectives. And I'd love to hear different perspectives, so let's start with the questions that is already on the chat box here from Ines, maybe. Okay. If you had the opportunity to introduce one global policy tomorrow to align AI development with sustainability, what would you prioritize and why? Maybe we can start with Miss Clarence. Your microphone.
Sorry. I think they are pertaining to the areas when it comes to
Mhm.
the sustainable technology. I think um personally I will prioritize more on the energy management, since here in the Philippines, one of our major problems, especially in the remote areas, are the energy consumption, because some of the communities doesn't have electricity, so they are relying into what we call the natural resources, like the uh, windmills. Like for example, in the what I um, discussed earlier is about the Pililio wind farm. So yeah, I think if I'm going to prioritize something, I think it's about the energy, and also with the integration of AI to make it more smarter when it comes to energy consumption management. So that's my take for that question.
I see. It's very incredible insight. So more on the management rather than what to take, what steps should we take. Okay. Maybe we need more perspectives on this too. So Miss Maya, maybe have your perspective on this question.
Okay, if I had the opportunity to introduce one global policy tomorrow to align AI development with sustainability, I would prioritize the establishment of a global sustainable AI government framework, a policy that integrates environmental responsibility, ethical AI development, and secure data governance into every stage of the AI life cycle. The reason is simple. AI is no longer just a technological tool. It is becoming critical infrastructure that shapes economic system, environmental decision, and social behavior worldwide. Without coordinated government, AI innovation may accelerate efficiency, but also increase energy consumption, data exploitation, risk, and social inequality. Why prioritize this? Because sustainability challenge, climate change, resource optimization, smart infrastructure are global problems. AI developed under fragmented national regulation cannot effectively address global risks. And fight framework would align innovation with long-term planetary and social well-being. Sustainable AI is not only about smarter system, but about responsible system that are secure, efficient, and beneficial for future generation. Okay, it's enough for me.
All right. I hope this answers your question, Miss Ines, and may this wisdom be useful to all of us. So we will move to the second question that we already have here from Terry Johann. Many young engineers are strong technically, but struggle to connect AI work with real environmental impact. Beyond coding, what mindsets or soft skills will be essential? Maybe Miss Maya, you may continue first before we move to Miss Clarence.
Okay, thank you, Terry Joanne. This excellent question. You are absolutely right. Many young engineers today are technically strong, but sustainability challenges require more than technical excellence. To connect AI innovation, real environmental impact, engineers must develop several essential mindset and soft skills beyond coding. First, system thinking. Environmental problems are complex and interconnected. Engineers must learn to see AI system not as isolated algorithms, but as part of large ecosystem involving energy consumption, human behavior, policy, and infrastructure. This mindset helps engineers as not only can we build it, but also what impact will it have. Second, sustainability awareness and ethical responsibility. Young engineers need to understand that every AI model has environmental and social consequences, from data center energy use to algorithm decision making. A responsible engineer evaluated efficiency, fairness, and long-term sustainability alongside performance metric. Third, interdisciplinary collaboration. Real environmental solution emerge when engineers collaborate with environmental scientists, policymakers, economics, and communities. Communication skill and opens to other disciplines become just as important as a programming skill. Fourth, problem-oriented rather than technology-oriented thinking. Instead of starting with technology, engineers should begin with real problems. The key question shifts from how can I use AI to what environmental problem truly need solving and is AI the right tool. Fifth, lifelong learning and adaptability. Sustainable engineering evolves rapidly. Engineers must continuously learn about green technologies, responsible AI practice, and emerging sustainable standards. In summary, future-ready engineers will success not only because they can design intelligent systems, but because they can meaningful, responsible, and sustainable solution. Technical skill build the system, but mindsets determine its impact. Thank you.
All right. Thank you, Miss Maya. That's a very powerful perspective. Um, so we would like to hear from Miss Clarence perspective too.
Well, actually, with that question, I um actually experienced that way back when I was a student. So connecting AI with the real environmental impact is really hard to do. But what are the mindsets or the soft skills that are very essential for this? Is first you have to be observant. Why? You have to observe your environment. What are the things or what are uh should what are the things that should I focus that where I can integrate AI, and Also, it can also help you to revisit the resources. Like for example, like what I've discussed, the 17 SDGs, you can get some idea from that. And then you can dig down once you choose what area you want to focus. For example, you want to focus about the environment. So you can start to take down from there. No, and also another skills that you have to develop or essential when it comes to uh this kind of task is to be persevere. Why? Because if you're not persevere with your work, you can be easily give up, and you have to always uh focus and think uh what what is the reason why are you doing this? No, why do you want to integrate AI in the real setting? So for example, you want to help a certain community to build a better future for the children, for example. No, so these two are for me are the essential to help you connect AI in the real environmental setup. So yeah, thank you.
Okay, thank you, Ms. Clarence, for the insights. I hope with both insights from our integrated speakers, you now have more understanding about the soft skills to continue building your career, Mr. Terry. Um, we will continue to our third question that we already have from Shane. We're under pressure to adopt AI for environmental planning, but honestly, many of us don't fully understand how the models make decisions. How important is explainability when AI is used for public environmental policies? Maybe we can start from Miss Clarence' perspective of the
Okay,
question.
okay, thank you. So for Miss Shane, no? Okay. So when it comes to adopting AI for environmental planning, as well as understanding when it comes to how AI model works to make decision, no, and also the importance of explainability when it comes to AI for public environmental policies. I think one thing I could advise is to utilize AI to first to understand what models you want to target. For example, um, you want to integrate an example of AI model, the YOLO. So you don't know how to integrate it into a specific project, like for example, environmental planning. So you can utilize like ChatGPT to explain further to you how this model works. And personally, it really helps me to understand how this model works and make decision. And when it comes to explainability about AI and for public environmental uh, policies, so AI is more on the smart computer systems that help humans analyze, predict, and automate complex tasks. So we have to remember that um, when it comes to AI, uh, explainability in AI understands why AI made a decision, and it helps. For example, AI helps in monitor electricity usage and optimize power distribution, especially in areas in unstable power grids. That's an example. No, so also it all AI use in when it comes to for public environmental uh policies, no, it is also important to know the the AI policies when it comes to your target project, for example, in environmental planning. So I think that's I can share when it comes to your question with that. So thank you.
Thank you, Ms. Clarence. We will continue with Ms. Maya's perspective of the question.
Okay, thank you, Sam. Explainability is not just important when AI used for public environmental policies. It's essential. In fact, without explainability, AI should not be trusted to support decisions that affect ecosystem, public resources, and communication. Environmental policy decisions often involve long-term consequences, uncertainty, and public accountability. When AI model recommended action such as land use planning, climate risk prediction, or resource allocation, policymaker and citizen must understand why a decision is made, not only what the prediction is. Accountability and public trust must be transparent. If an AI system recommends relocating communities due to flood risk or prioritizing certain conservation areas, stakeholders need clear reasoning. Explainable AI allows policymakers to justify decision ethically and legally. AI model can inherit bias, incomplete data, or hidden assumption. Explainability help expert identify whether a model recommendation is based on meaningful environmental pattern or misleading correlation. Without this, incorrect decision could cause ecological or social harm. In practice, this means we should prioritize interpretable models, transparent data source, and explainable AI technique, even if they are sometimes slightly less complex than black box model. AI must be accurate, transparent, and understandable because sustainability depends not only on smart technology, but also on informed human trust and responsible governance. Thank you.
All right. Thank you, Ms. Maya, for the insight. I hope this answers your question and enrich your knowledge about AI's role for public environmental policies. And then we will move to the fourth question from Lawrence. In regions with unstable power grids, IoT systems sometimes fail. How reliable are IoT energy management systems in developing infrastructure context? We will start from Ms. Maya for the
Okay,
perspective.
thank you, Lawrence. IoT energy management system can be reliable in developing infrastructure context, but only they are designed with resilience as a primary objective, not as an afterthought. Many IoT solutions are originally designed for stable, high infrastructure environment. When deployed in region with unstable power grid, connectivity interruption, or limited maintenance resource, failures often occur not because the technology is weak, but because the system architecture is not context aware. Instead of depending entirely on cloud connectivity, modern IoT energy systems should process data locally and the edge. This allows device to continue operating and making decisions even during internet or power interruption. Reliable system integrate backup power source such as batteries, solar microgrid, or low power operating model. Device must be capable of graceful degradation, meaning they continue essential function even under limited energy condition. In developing infrastructure content, systems should assume an intermediate connectivity. Data synchronization can occur when connection return rather than require continuous online operation. So, reliability is not only a technology issue, it's a design philosophy. When I have energy management system adapt to local infrastructure realities, they can significantly improve energy efficiency, reduce outtakes, and support sustainable energy transition, even in challenging environments. IoT systems are reliable in developing region when they are built to be adaptive, decentralized, energy efficient, and human-centered rather than dependent on perfect infrastructure. Thank you.
All right. Thank you for the insight, Miss Maya. We can continue to Miss Clarence' perspective on the question.
So when it comes to IoT systems, so IoT energy management systems are really helpful, but still it's not perfectly reliable in a certain areas. So IoT energy management can monitor electricity, detect power outages quickly, and also support smart grids. However, there are several challenges like what Lawrence raised. Like for example, frequent power interruption, unstable internet connectivity, and higher initial deployment costs. This is because IoT devices are depend on the continuous power and network connection. So IoT energy management systems are promising and effective, but their reliability improves only when supported by first, stable power supply, second, reliable internet networks, a backup system, for example, a battery or edge computing, and lastly, proper infrastructure investment. So that's my answer for that question. Thank you.
All right. Thank you, Miss Clarence, for the insights. I hope this answers your question, Miss LaFrance. And now we have another question, our last question from live chat on our YouTube channel. That, thanks for interesting sharing about AI. May I ask, how can AI be used in tourism promotion? What forms does it take? Are there any factors that influence it? Thank you. From Ligid Bisuputra. Maybe Mr. Clarence could start with her insight.
Actually, there are a lot of applications of AI when it comes to tourism promotion. One best example is uh, the image recognition, wherein they can use it to recognize a specific um, tourism place or tourism destination and provide information to a tourist. And also, we can use this in the museum to provide information also to the tourists. Just like the example I've mentioned earlier with one of my students, they develop an application with image recognition wherein you just point the camera of your phone to the a specific object inside the museum and it will give you a useful information about that artifact. So that's one of the best example of AI. And again, there's a lot of areas in AI that you can use for tourism promotion. So yeah, thank you.
All right. Thank you, Miss Clarence. we will continue to Miss Maya's perspective on the question.
Okay, thank you. AI can play a significant role in tourist promotion by transforming how destination understand visitors with experiences and communicate with global audience. In general, AI help tourism move from mass promotion toward personalized and intelligent promotion. AI analyze traveler preference, search behavior, and past visits to recommend destination, hotel, cultural attraction, or travel routes tailored to individual tourists. This increases engagement because promotion becomes highly relevant to each user. AI can generate promotional content such as travel description, social media campaign, videos, and multilingual advertisement automatically, allowing tourism agencies to reach international market efficiently. AI analyze travel trends, seasonal demand, and visitor data to help governments and tourism operators design smarter promotional strategies and manage tourism flow sustainability. Technology such as AI-based translation, smart guides, and augmented reality enhance visitor experience as destination, making tourism more interactive and accessible. AI and tourism promotion is not only about automation, but about creating smarter, personalized, and sustainable tourism ecosystem that benefit both visitor and local communities. Thank you.
All right. Thank you, Miss Maya, for the insight. And I hope this answers your question and may this wisdom be useful to all of us. Now, now that we're done with the Q&A sessions and as we near the end of this webinar, let's immortalize this moment with a group photo. It will be a great memory to keep and of course for documentation purposes too. Please activate your cameras and wear your best smiles. I'll count down to capture the moment. Okay, I will count from one, 2, 3. Once again for good measure. 1, 2, 3. All right. Thank you so much. As we conclude this remarkable international webinar, it's time to reflect on the knowledge, connections, and valuable insights we've gained throughout. Before we officially close, I would like to express our deepest gratitude to all of our distinguished speakers, our diligent organizing team, and all of you enthusiastic participants. Your active engagement, thoughtful questions, and diverse perspectives have enriched this webinar. Today's webinar exemplifies the power of global collaboration and the incredible potential of technology to connect individuals across borders and cultures. It underscores our commitment to pursuing knowledge and fostering international dialogue and understanding. As we conclude this virtual gathering, I encourage you to carry forward with the ideas and connections for today. Let the discussions and insights gain inspire your future endeavors and collaborations. Remember that the quest for knowledge knows no boundaries, and the bonds we form here can extend far beyond this virtual platform. Let's stay connected, continue the conversations, and work together to address the challenges and opportunities that lie ahead in the global stage. Thank you once again for being an integral part of this international webinar. We eagerly look forward to welcoming you to future events where we can continue our journey of learning, collaboration, and making a positive impact on our interconnected world. Until we meet again, take care, stay inspired, and keep exploring the vast realm of knowledge. Farewell, and have a wonderful day or evening, wherever you may be. And for the PowerPoint, Okay, Miss Clarence has already sent her PowerPoint. Let's see.